All right, so next up I want to talk about the relationship between linear speed and angular speed. And I want to do this by looking at this wonderful comic from Calvin and Hobbes where Calvin is getting messed with by his poor dad. So his dad says, playing a record, Calvin, I'll show you something interesting. Compare a point on the label with a point on the record's outer edge. They both make a complete circle in the same amount of time, but the point on the record's edge has to make a bigger circle in the same time so it goes faster. See, 2 points on one disc move at two speeds, even though they both make the same revolutions per minute. This is a fantastic comic. It's a great way to troll children. Just everything about this is great. And of course, Bill Watterson, Calvin Hobbes, both fantastic. Okay, so looking at a circle, this is our record. We've got the label on the inside of the circle. Those of you who aren't familiar with records, I imagine a lot of you are. We've got the record is spinning around this central point. We've got the label, the artist info right here in the middle, and then the part that actually records the music. And they're all fixed on one disc. So we're talking about 1 point here on the outside of the circle, and 1 point here on the outside of the label. And this thing is moving, and just like Calvin's dad says, this one on the outside has to be going faster because it's going a greater distance. And you can see, just looking at this, this is a large distance, and this one inside, this is a much smaller distance. And just like when people are racing, they want to stay on the inside of the track because it's a smaller distance. A lot of times that's where you want to be. As opposed to outside, you have to go a longer distance. So, how can this be true? Poor Calvin, he can't figure it out. Fortunately, we can. So we're going to talk about that now. So what exactly is going the same speed here? Is it the linear speed? Clearly not. He's going a larger distance. The point on the outside of the circle is going a larger distance. That has to be a faster linear speed, just like his dad says. And the one on the inside it would have to be going a slower linear speed. Where he's messing with Calvin is the angular speed. The angular speed does have to be the same because any point, like I move this point from here to here, I've gone through some angle, theta. This point also went through that same angle. So the angular speed has to be the same. The linear speed does not. So how are these linear speeds related to each other? It's actually really simple. I've got the algebraic way written here for you, kind of outlined what's going on. But the length is proportional to the radius here. As the radius increases, the linear speed increases. So the rule here is that the linear speed is linearly proportional to the angular speed. A simpler way of saying that is it's r times omega. Nice omega there. So as the radius increases, the linear speed, which is the radius times the angular speed, that would also have to increase. So that's a nice way of memorizing it if it helps you. As the radius increases, the linear speed has to increase. So a great visualization of this rule, which is going to be immensely important for problems like this that involve two circles with the same angular speed. Now, actually, I don't think MyMathLab had any great examples. Your textbook is full of these things. For some reason, MyMathLab didn't have any great ones. If I find any, I will throw those in there. But I didn't see any my first time through, which is very disappointing. But this is a really common reality of engineering, where you have the same angular speed, and we want to use that to translate. We want to change linear speeds using this. Sometimes you'll have one big gear, right, and on its axle there, attach that same hub, going to that same axle, we have a smaller gear that allows us to change the linear speed of our motion. That's actually a really common type of engineering problem. Again, no fantastic problems for that in our MyMathLab for some reason. So unfortunately, you get to miss out for that. All you get is this beautiful example from Calvin's dad. I do have a great example going the other way, which I'll do for you right now.